Imagine standing or perhaps floating somewhere within that environment. There may not even be a solid surface to stand on. Gravity would feel heavier than Earth's, pulling gently but firmly, while the thick air presses around you like a warm ocean. Sound would travel differently there. Dense gases would carry vibrations farther, slower, deeper. The planet itself might hum, a low, continuous murmur created by wind currents sliding through layers of atmosphere hundreds of kilometers thick. If life exists on K218b, it likely does not rush. Nothing about this world suggests urgency. There are no sharp seasons, no sudden freezes, no blazing summers. Change happens slowly, over thousands or millions of years. Evolution would be patient, methodical, like a long breath held steady. Instead of predators chasing prey across land, life might drift, absorb, filter, and recycle. Entire ecosystems could exist as floating layers, stacked like pages in a book, each tuned to a slightly different pressure and temperature. Some organisms might live high in the atmosphere, suspended like living clouds, feeding on chemical gradients and faint light. Others might dwell deeper, where the hydrogen-water ocean grows dense and dark, relying entirely on chemistry. Energy would flow upward and downward, not outward. A vertical biosphere instead of a horizontal one. Life arranged by depth, not latitude. This idea once sounded impossible, but we already know it works. On Earth, bacteria live miles above the surface, drifting in the stratosphere. Others thrive kilometers below the ocean floor, feeding on rocks. Life here already ignores the boundaries we once believed were absolute. K218b simply takes that lesson and scales it up to a planetary level. What makes this discovery so powerful is not just that life may exist there, it's that life may exist there times easily, comfortably. As if the universe itself set the stage and then stepped back to let chemistry do what it does best. Combine the right ingredients, give them time, and life appears. For decades, our search focused on Earth-like planets because we only knew one example of success: blue skies, green plants, oxygen, continents. But that was never a rule. It was a single data point. K218b tells us that life doesn't need familiar scenery. It doesn't need trees or animals or even sunlight in the way we understand it. It needs stability, energy flow, and time. And time is something this system has in abundance. The red dwarf star hosting K218b will outlive our sun by a factor of 10 or more. While our star will swell and erase Earth long before the universe grows old, this one will continue glowing quietly. If life took hold on K218b a billion years ago, it may still be thriving billions of years from now. Entire evolutionary stories could unfold there that never face extinction-level resets. Intelligence, if it ever arises, would have unimaginably long stretches to develop. That possibility changes the way we think about ourselves. If life is common around red dwarfs, then the galaxy may be filled with living worlds that formed long before Earth and will survive long after it. Civilizations, if they emerge, may be ancient beyond comprehension. Not louder or more aggressive, just older, more practiced at existing. And suddenly, the question shifts. It's no longer, is there life out there? It becomes, how many forms of life are already out there, quietly continuing their stories while we're just beginning ours? When the data from K218b was first circulated, many scientists reacted with cautious restraint. Not denial, but humility. This wasn't a single signal or a blurry image. It was a consistent chemical story told across multiple observations, multiple transits, multiple instruments. Each pass of the planet in front of its star reinforced the same conclusion. The atmosphere was not drifting toward equilibrium. Something was actively maintaining it. That is the fingerprint of life. Still, science moves carefully. A 99.7% probability is extraordinary, but it stops just short of absolute certainty. There are still questions. Could unknown chemistry mimic these signals? Could exotic processes we haven't yet imagined explain dimethyl sulfide without biology? These questions are not obstacles, they're the next steps, and they're already being taken. Future observations will refine the picture. Longer monitoring periods will reveal seasonal changes, if any exist. Deeper spectral resolution may uncover additional molecules that strengthen the case even further. Other telescopes will join the effort, each adding another layer of confirmation. This planet will not be forgotten. It has become a priority target, a benchmark world. But even now, before those future confirmations arrive, something fundamental has already shifted. We are no longer searching in the dark. We have crossed from guessing to measuring, from wondering to detecting, from imagining life elsewhere to nearly touching it with data. And that moment matters. Because once you know that life can arise easily under alien skies, you can never look at the universe the same way again. Every faint star becomes a potential harbor, every red glow a possible cradle. The night sky stops being empty and starts feeling crowded in the most comforting way possible. Not crowded with threats, crowded with stories. Worlds where oceans breathe under crimson suns. Worlds where chemistry learned to organize itself into living systems long before humans looked up and asked if they were alone. K218b does not answer every question. It opens them, and that is exactly what a great discovery should do. It tells us that life is not a miracle confined to one small blue dot. It is a natural outcome of a patient universe that knows how to reuse its rules in endlessly creative ways. And if that is true, then this discovery is not the end of a search. It is the beginning of a conversation that will last as long as our species does. The more researchers sat with the implications of K218b, the more uncomfortable the silence became. Not the silence of doubt, but the silence that follows when something feels too large to speak about casually. In conference rooms, in late night calls, in private notes, never meant for press releases, the tone shifted. This was no longer a hunt for another data point. This was the first time humanity had brushed against a second living system, and it forced an uncomfortable realization. If this planet is alive, then life did not wait for us. It did not need us. It did not mirror us. It simply happened. That realization hits deeper than any announcement ever could, because for generations, life elsewhere was treated like a prize at the end of a long road. Something rare, something fragile, something that would validate us. But K218b doesn't feel like validation. It feels like correction. A reminder that biology may be a rule, not an exception. When scientists model the planet's atmosphere over time, they see stability that borders on eerie. Decades of simulated evolution show the same patterns repeating, the same balance holding. Methane rises, then falls. Carbon dioxide cycles. Water vapor remains steady. Nothing spirals out of control. Nothing collapses. It is the signature of a mature system, not a young one still finding its footing. Which means if life is there, it may not be simple. Simple life doesn't usually achieve equilibrium on a planetary scale. It experiments, it overshoots, it crashes. Earth's history is filled with such scars: oxygen catastrophes, snowball phases, mass extinctions. Yet K218b shows none of those fingerprints, at least not in the atmospheric snapshot we see. Its chemistry looks settled. That opens a quiet, unsettling possibility. Life there may not just exist, it may have already passed through its most dangerous phases. If intelligence ever arises on such a world, it would be born into stability, not chaos. It would grow up under a sky that does not threaten it, oceans that do not vanish, a star that does not rage. Its relationship with its environment would be cooperative by default, not adversarial. That alone could shape an entirely different kind of thinking. Human intelligence was forged in struggle, scarcity, competition, extinction pressure. We learned to dominate because the world demanded it. But on K218b, dominance may never have been necessary. Survival would reward balance instead of conquest. Intelligence there, if it exists, might value continuity above expansion. And that brings an uncomfortable mirror back to us. Because when we look for life elsewhere, we are also asking a quieter question. What kind of life are we? The planet's distance matters here. 120 light years is far enough that any signal we detect is already history. The chemistry we're seeing reflects a living system as it was when humans still believed Earth was the center of everything. While we were learning to fly, that planet may already have had ecosystems older than our civilizations. That time gap creates a strange emotional distance. We are not observing a newborn biosphere. We are witnessing a survivor, a system that has already endured what we have not yet faced. Some scientists struggle with that emotionally more than intellectually. There's comfort in imagining alien life as primitive, as something we might one day surpass or understand completely. K218b challenges that comfort. It suggests that elsewhere, life may already be refined, settled, complete, and we are the late arrivals. As more teams reanalyze the data, they begin asking second-order questions. If dimethyl sulfide is present, what is producing it? On Earth, the dominant source is marine life, phytoplankton, microorganisms that float, multiply, die, and recycle endlessly. If something similar exists on K218b, its oceans may be filled with living matter on a scale we can barely imagine. Not forests, not animals, but planetary-scale microbial seas, alive in every direction. Life there may not concentrate into bodies the way it does here. It may diffuse, spread, become the environment itself, a world where the distinction between organism and ecosystem dissolves. That kind of life would not build cities. It would not launch rockets, but it would endure, and endurance, in cosmic terms, is the rarest achievement of all. This reframes the way we think about intelligence. We often assume intelligence must look outward, must manipulate, must build. But what if the most successful life never needed to? What if awareness can exist without expansion? What if consciousness does not always lead to technology? K218b forces us to consider that possibility. A living planet that has no reason to change, no incentive to leave, no pressure to compete. A biosphere content to remain where it is, stable and self-sustaining. And if such worlds are common, then the universe may be full of life that simply has no interest in being loud. Which brings us to a quieter, more personal realization. We have been listening for signals, radio bursts, lasers, artificial noise. But if most life does not speak in those ways, then silence does not mean absence. It may mean satisfaction. The James Webb Space Telescope did not hear a message from K218b. It smelled one. It tasted one. Through light, it detected metabolism, not intention. And that may be the most honest form of contact we could hope for. Because before intelligence, before language, before technology, life announces itself in chemistry. Breathing alters atmospheres. Metabolism leaves fingerprints. Survival writes itself into the air. That is what Webb saw. Not a greeting, not a warning, a presence. And presence alone is enough to change everything. The longer this sinks in, the more it reshapes our sense of place. Earth stops feeling like the stage and starts feeling like one chapter among many. Not diminished, not erased, just contextualized. We are not special because we are alive. We are special because we are aware of it. And now, for the first time, we are aware that life elsewhere may be aware of itself too. What happens next will not be dramatic. There will be no sudden announcement of certainty, no declaration of, "we have found aliens." Science does not move that way. Instead, there will be patience, more data, more refinement, more careful language. But internally, something has already crossed a threshold. We no longer ask the universe if it can host life. We ask how often it does. And once that question takes hold, it never lets go. The shift is subtle, but once it happens, it can't be undone. The universe no longer feels like a vast, empty stage waiting for a single performance. It starts to feel like a crowded library, most of whose books we haven't learned how to read yet. K218b becomes one of those books. Not because it's dramatic, but because it's calm. Researchers begin revisiting old assumptions with fresh discomfort. For years, habitability was defined by comfort for humans. Liquid water, yes. Mild temperatures, yes. Oxygen, preferably. But oxygen itself is a biological invention. For most of Earth's history, it was toxic. Life thrived long before it appeared. K218b reminds us that we may be looking for the wrong comforts. Life doesn't need familiarity. It needs gradients. Energy moving from one place to another. Chemistry that refuses to settle. That's it. And K218b has all of that in abundance. The hydrogen-rich atmosphere that once disqualified this planet is now understood as its greatest strength. Hydrogen is light. It spreads heat efficiently. It cushions the planet against extremes. Instead of deserts and ice caps, it produces moderation everywhere. A global climate without sharp edges. Models show that storms there would not be violent. Winds would move slowly but persistently, driven by small temperature differences rather than dramatic pressure drops. Rain would fall, not in bursts, but in long, gentle cycles. Oceans would rise and fall gradually, never retreating completely, never freezing solid. If life emerged in such conditions, it would never experience the fear of collapse. No sudden ice ages, no runaway greenhouse effects, no asteroid-triggered extinction cycles every few 100 million years. That stability changes evolution itself. On Earth, complexity emerged through crisis. Each mass extinction cleared space for new forms to arise. But on K218b, complexity could emerge through accumulation instead. Layer upon layer of adaptation, stacked patiently over deep time. Life there might not explode into diversity. It might deepen. Instead of branching wildly, it could refine, optimize, specialize vertically through the atmosphere and ocean depths. Each layer hosting organisms perfectly tuned to that narrow band of pressure and chemistry. Such a biosphere would be hard to disrupt, hard to kill, almost impossible to erase. And that brings us to a quiet but important realization. If life is this robust, then the universe doesn't just tolerate it. The universe encourages it. Stars like K2-18's red dwarf are everywhere. Roughly 70% of the Milky Way stars fall into this category. If even a small fraction hosts planets like this one, then living worlds are not rare outliers. They are a dominant feature of the galaxy, which means Earth may not be the template. It may be the exception. This doesn't diminish us. It contextualizes us. Our planet is dramatic, volcanic, chaotic, alive in bursts. K218b may represent the opposite path, a slow-burning biosphere that never needed drama to thrive. As this sinks in, scientists begin to speak differently about the future of exploration. Instead of focusing solely on Earth-like worlds, attention broadens. Hydrogen worlds, ocean worlds, atmosphere-dominated worlds. Entire classes of planets once ignored now rise to the top of target lists. The James Webb Space Telescope was built for this moment. Its infrared vision is perfectly suited to red dwarf systems. Each new observation adds another data point, another chance to see whether K218b is unique or merely the first clear example. Already, similar candidates are being queued. Worlds with thick atmospheres, warm equilibrium temperatures, chemical imbalances that hint quietly, persistently at metabolism. The universe is starting to whisper back. And what it's saying is not extraordinary in the way we expected. It's saying life is normal. That idea is more destabilizing than any alien encounter scenario ever imagined. If life is normal, then intelligence may also be normal. And if intelligence is normal, then we are not early. We are not late. We are simply one voice among many at a particular stage of awareness. K218b forces us to accept that our timeline may be average. Somewhere out there, life may be younger. Somewhere else, far older. Some worlds may already be past their technological phases, having chosen stability over expansion. Others may still be microbial seas, unaware of the stars above them. The cosmos becomes a spectrum of living states, not a binary of alive or dead. And for the first time, we have evidence that places us firmly inside that spectrum. The discovery also changes how we think about silence. If life is common but intelligence does not always lead to communication, then the quiet sky makes sense. Most life does not announce itself. It breathes. It persists. It cycles. K218b did not send a message. It left a chemical trace, and that trace traveled 120 light years to reach us. That alone is astonishing. Light crossed interstellar space for more than a century, carrying the byproducts of living chemistry, only to arrive at a telescope we built just in time to notice. The timing feels almost poetic, but it's really just physics meeting curiosity. We didn't summon this discovery. We were finally ready to see it, and that readiness marks a turning point. From here on, every future telescope, every future mission, every future model will be shaped by this moment. We will search differently. We will interpret data differently. We will no longer ask whether biology is possible elsewhere. We will ask how it manifests. And that question is far richer. It opens doors to life forms we haven't imagined. Ecosystems without surfaces, biospheres without oxygen, intelligence without cities, awareness without expansion. K218b stands as proof that the universe's creativity exceeds our expectations. Not because it made something strange, but because it made something stable. And stability in a universe driven by entropy is the most remarkable achievement of all. As the weight of that idea settles, another layer of the story begins to surface. One that has nothing to do with telescopes or molecules, but everything to do with perspective. For the first time in human history, we are not imagining life elsewhere based on hope or philosophy. We are inferring it from balance, from ratios, from chemistry that refuses to sit still. And that subtle shift is what separates science from belief. K218b does not ask us to believe in aliens. It asks us to accept math. The ratios of gases in its atmosphere don't argue. Methane and carbon dioxide shouldn't coexist in those proportions for long. They react, they neutralize, they settle, unless something is constantly replenishing them. On Earth, that something is life. Not intelligence, not civilization, just metabolism. Countless tiny processes, repeating endlessly, shaping a planet without intention. That's what makes this discovery so unsettlingly calm. There is no drama in it, no flashing signal, no sudden movement, just a planet quietly breathing. And that quiet breathing forces scientists to confront a long-standing bias. We've been searching for noise, for disruption, for things that look like us. But the universe may prefer subtlety. It may favor systems that last, not systems that shout. When researchers at the Harvard-Smithsonian Center for Astrophysics ran long-term simulations of K218b's atmosphere, one result stood out. Even when models introduced disturbances, increased stellar activity, minor orbital shifts, the system recovered. The chemical balance returned. The temperature stabilized again. Resilience. That word begins to appear more often in internal discussions. Not habitability, not Earth-like, resilient. A resilient biosphere doesn't collapse easily. It doesn't depend on narrow conditions. It adapts without catastrophe. And if life exists on K218b, it has likely been resilient for a very long time. That has implications far beyond one planet, because resilience scales. If life can achieve this level of stability around a red dwarf, then entire regions of the galaxy could be filled with worlds that simply persist, not rising and falling like ours, but continuing quietly while stars drift and galaxies evolve. Suddenly, the Milky Way stops feeling young. It starts to feel seasoned. The James Webb Space Telescope was never meant to answer philosophical questions. It was built to measure heat, light, and chemistry. But by doing that honestly, without assumptions, it has forced philosophy back into the conversation. What does it mean to live in a universe where life is common but not conspicuous? What does it mean if most living worlds never develop technology, not because they can't, but because they don't need to. And what does it say about us that our first instinct upon realizing we might not be alone is to ask why no one is talking to us? K218b doesn't talk, it doesn't signal, it doesn't announce, it exists. And that may be the most mature state life can reach. This idea creates tension in how future missions are discussed. Some argue that if life is widespread but quiet, then active messaging, broadcasting our presence loudly into the galaxy, may not be wise. Others argue the opposite, that contact is inevitable and curiosity is universal. But K218b offers a third possibility, that contact isn't avoided, it's irrelevant. If most life is content, if most biospheres are stable and enduring, then interaction with younger, noisier species may simply not matter. Not out of hostility, out of disinterest. That's a hard idea for us to sit with. Because humans are a narrative species. We expect stories to have arcs, conflicts, resolutions. We expect discovery to lead somewhere dramatic. But nature doesn't owe us drama. It owes us accuracy. And the accurate picture emerging from K218b is this. Life does not rush toward intelligence. It does not strive for expansion. It doesn't seek meaning. It seeks continuation. Meaning is something intelligence invents later. That reframes how we should think about intelligence elsewhere, not as an inevitable outcome, but as one branch among many, a risky branch, a fragile one. A branch that can easily collapse under its own complexity. On Earth, intelligence has nearly ended life multiple times. Nuclear weapons, climate destabilization, ecological collapse. These are not signs of superiority, they are symptoms of imbalance. K218b shows us a different path, a planet where balance may have been achieved early and maintained patiently. And that realization stings because it suggests that intelligence may not be the peak of evolution. Stability might be. This doesn't mean intelligence is doomed or pointless. It means it carries responsibility. If we are rare, it's not because intelligence is hard to create. It's because it's hard to survive. And if we are to survive, we may need to learn from worlds that never needed to change much at all. The red dwarf that warms K218b will not dramatically evolve. It will not swell into a red giant anytime soon. It will not strip the planet's atmosphere away. It will simply continue, steady and predictable. That star has already outlived our sun in terms of future lifespan. So when we look at K218b, we are not just seeing a living planet. We are seeing a possible long-term future for life itself. Not expanding outward, not conquering space, but settling into a sustainable equilibrium and staying there. This challenges one of our deepest assumptions, that the purpose of intelligence is exploration. What if the purpose of intelligence is restraint? What if the most advanced civilizations are the ones that never leave home? Not because they are trapped, but because they have no reason to go. K218b may not host intelligence, or it may host something so old and subtle that it leaves no technological footprint we can detect. Either way, the lesson is the same. Life does not need us to witness it to be real. And the universe does not need us to be central, to be meaningful. As this idea ripples outward, the discovery begins to influence how future generations will be taught to look at the sky. Not as a place of emptiness to be filled, but as a place already full. Full of processes, full of chemistry, full of worlds quietly minding their own existence. The sky stops being a challenge. It becomes a neighborhood. And we are no longer asking if anyone else lives there. We are asking how to be good residents. That shift in perspective begins to change how scientists talk when they think no one is recording. The language softens. Less conquest, less urgency, more listening. At NASA's Jet Propulsion Laboratory, long-term planners have started to quietly adjust their internal models. Not public mission statements, not press releases, but the assumptions that sit underneath them. If worlds like K218b are common, then the galaxy isn't waiting for us. It's already busy. And that realization does something unexpected. It slows people down. Because once you accept that life may already be widespread, the pressure to rush toward discovery fades. Discovery becomes inevitable, not urgent. What matters instead is interpretation. understanding what we're seeing without forcing it into human stories. This is why the James Webb data is being reanalyzed again and again. Not because scientists doubt it, but because the implications are so large that everyone wants to be absolutely sure they're not projecting hope where none exists. Every alternative explanation is tested. Could dimethyl sulfide be produced by unknown geology? Could extreme pressure chemistry mimic biological signatures? Could we be misreading overlapping absorption lines? Each time, the answer circles back to the same place. Not impossible, just unlikely. Extremely unlikely. The models don't collapse, they tighten. And slowly, reluctantly, the scientific community begins to speak in probabilities rather than possibilities. That's where the 99.7% comes from. Not from hype, from exhaustion, from ruling everything else out. In particle physics, a 3 sigma result would barely raise eyebrows. But in astrobiology, where uncertainty has always ruled, it lands like thunder. It means we're not standing on the edge of a question anymore. We're standing inside an answer that doesn't yet have words. The public conversation, however, lags behind. Headlines simplify. Social media amplifies. Some people jump straight to intelligent aliens, others dismiss the entire thing as exaggeration. But neither extreme captures what's actually happening. This isn't about aliens visiting Earth. It's about Earth losing its exclusivity. For thousands of years, life here was assumed to be special by default. Then it became special by complexity. Now, it may simply be one example among many, and that realization is deeply unsettling. Not because it threatens us, but because it humbles us. K218b doesn't care if we notice it. Its atmosphere doesn't pulse faster because we look. Its oceans don't warm or cool in response to our excitement. Life there, if it exists, is indifferent to our discovery. And that indifference may be the most honest signal the universe has ever sent us. Think about how different this is from our early expectations. We imagined alien life as something that would arrive, announce itself, disrupt us. Something dramatic. But reality, as it often does, is quieter. A faint dip in starlight, a whisper of sulfur, a balance that refuses to break. This is how the universe communicates, not with declarations, but with consistency. The deeper scientists look, the more they realize that K218b may not even be exceptional. It may simply be the first world close enough, quiet enough, and cooperative enough for us to notice. And that thought opens a door that cannot be closed. If one such planet exists 120 light years away, then statistically there should be dozens within 500 light years, hundreds within 1,000, thousands across the galaxy. Most of them will never speak. Most will never build radios or rockets. They will live and die in silence, their oceans cycling, their skies breathing, their chemistry humming along without witness. And yet, they will matter. They matter because they tell us something about the universe's preference. Not for spectacle, but for sustainability. Stars like red dwarfs don't burn brightly, but they burn forever. Planets like K218b don't sparkle, but they endure. Life that grows there doesn't rush, but it lasts. In that sense, our own world begins to look young and impatient. We chase growth, we chase expansion, we chase meaning. But perhaps meaning emerges naturally when survival is no longer in question. K218b may have passed that threshold long ago. And here's the quiet irony. The James Webb Space Telescope was built to look backward in time, to see the first stars and galaxies. Yet its most profound discovery may be forward-looking. It may be showing us what long-term success looks like. Not a shining civilization, not a galactic empire, but a planet that figured things out early and never needed to change much afterward. That idea doesn't sell toys. It doesn't fuel movies. But it may be the most important lesson astronomy has ever offered. Because if life elsewhere thrives by staying balanced, then our greatest challenge isn't finding others. It's learning how not to destroy ourselves before we become just another brief chemical fluctuation in the universe's long memory. The red dwarf continues to glow. The planet continues to orbit. the atmosphere continues to breathe. And somewhere beneath those clouds, chemistry may still be doing what it has done for billions of years, living. That quiet continuation forces one more uncomfortable realization, one that scientists don't usually say out loud, even among themselves. If life is common, then silence is normal. The absence of signals, megastructures, or visiting craft stops being a mystery. It becomes expected behavior. A galaxy full of life doesn't have to be loud. In fact, it may be mostly quiet by design. This reframes the famous question that has haunted astronomy for decades. Where is everybody? Maybe they're right where they've always been. Stable, balanced, uninterested in expansion, unaware of us, or aware and unconcerned. K218b becomes important not because it screams intelligence, but because it whispers persistence. When scientists at the European Southern Observatory began comparing K218b's atmospheric stability to long-term climate models of Earth, a troubling contrast appeared. Earth's atmosphere is alive, yes, but volatile. It swings, it overshoots, it reacts violently to small changes, ice ages, greenhouse spikes, mass extinctions, recovery, collapse. Renewal, K218b, shows no signs of that chaos. Its chemistry appears buffered, like a thermostat that rarely drifts far from center. Even stellar flares from its red dwarf don't seem to strip the atmosphere or disrupt its balance. The hydrogen layer absorbs shocks, redistributes energy, and protects the lower layers where water likely persists. It's a planet built for forgiveness. And that concept changes how scientists now think about habitability. Earth may be livable, but it isn't forgiving. It punishes mistakes quickly. K218b, by contrast, seems tolerant. Errors don't cascade. Feedback loops dampen rather than amplify. Life doesn't need to constantly fight for survival there. It can simply exist. That matters because survival pressure drives behavior. On Earth, scarcity shaped intelligence. Competition bred tools. Tools bred power. Power bred risk. On a world where scarcity is low and stability is high, intelligence may never need to arise. Or if it does, it may remain subtle, integrated, and invisible. That possibility unsettles us because it suggests intelligence isn't the universe's goal. Longevity is. The more data Webb sends back, the clearer this picture becomes. Not a fragile oasis, but a robust system. Not a miracle, but a pattern. At Stanford's planetary science groups, simulations now run with this assumption. If hydrogen-rich ocean worlds are common, then our galaxy may contain more living surface area beneath clouds than on all rocky planets combined. That flips the cosmic hierarchy. Earth-like planets were once thought to be the best places to look for life. Now, they may be the exception. Ocean worlds with thick atmospheres may be the rule. And if that's true, then life in the universe is not perched delicately on razor-thin conditions. It is spread out, cushioned, and resilient. Which brings us to a question that doesn't get asked enough. If life is everywhere, why are we so afraid of finding it? Part of the fear comes from stories we tell ourselves. Invasion, replacement, judgment. But K218b offers no hint of any of that. No technology, no structures, no energy use beyond what a living system requires. Just breathing. Life doesn't need to dominate to succeed. It doesn't need to spread aggressively. It doesn't need to announce itself. That realization strips away the drama and leaves something quieter and more profound. We are not early. We are not late. We are just one example among many. And like any young species, we assumed youth was special. As telescopes improve, this will not be the last such discovery. It will be the first of many. Worlds where chemistry dances out of balance, where atmospheres refuse to settle, where something keeps the system alive. The shock won't last. Normalization will. And when that happens, when life elsewhere becomes expected rather than extraordinary, humanity will face a strange moment of maturity. We will stop asking if we are alone and start asking what kind of neighbors we want to be. because the universe is not empty. It never was. We were simply late to notice that it was already full. As that understanding settles in, another layer of meaning quietly emerges, one that goes beyond astronomy and into identity. For most of our history, humans define themselves by contrast. Earth versus sky, life versus void, us versus nothing. But the discovery of K218b dissolves that contrast. The void isn't empty. It's textured, layered, alive in ways we're only beginning to recognize. And that changes how we see ourselves. We often imagine life as something that fights entropy, something constantly on the edge of collapse. But K218b suggests another model, life not as rebellion, but as alignment. Chemistry flowing in step with environment, energy moving without waste, systems designed not to expand, but to persist. That's an unsettling mirror to hold up to our own world. On Earth, we measure progress in speed. Faster travel, faster growth, faster consumption. Yet speed comes with friction, heat, loss, instability. The planet around that quiet red star appears to have chosen a different path. Slow cycles, long horizons, minimal disruption, and in cosmic terms, that path wins. This raises an uncomfortable possibility. That intelligence, as we define it, may not be the final form of life. It may be a transitional phase. A brief moment when a species becomes aware of the universe, experiments with control, and then either stabilizes or burns out. K218b doesn't show signs of burning out. If anything, it shows signs of having settled into a rhythm long ago. This is why some researchers are starting to talk about biospheres rather than civilizations. Civilizations rise and fall. Biospheres endure. From orbit, Earth would look alive, green, blue, active, but it would also look noisy, chaotic, scarred. In contrast, K218b would appear muted, clouded, calm. Yet beneath that, calm may lie far more total life than Earth has ever hosted. If that's true, then our instincts have been backward. We assumed visible complexity meant success, but perhaps invisibility is the mark of maturity. This perspective reframes the search for life entirely. Instead of asking where intelligence might build structures, we begin asking where chemistry has remained stable long enough for life to flourish uninterrupted. It also reframes silence. Silence no longer implies absence. It implies balance. A living world doesn't need to speak. It doesn't need to send signals. It doesn't need to leave monuments. It just needs to keep working. And that's exactly what the data from K218b suggests is happening. Each new transit observed by Webb reinforces the same picture, the same ratios, the same steady temperature, the same absence of chemical collapse. No drift, no decay. Consistency. In science, consistency is far more powerful than surprise. And consistency across time implies something deeply important, that whatever is happening on K218b is not temporary. It's not a flare-up of life. It's not a fleeting bloom. It's a system that likely began long before humans learned to look up. This realization forces us to confront another idea we've long avoided, that life may not be rare because it's difficult to start, but because we've been looking in the wrong places, with the wrong expectations. We searched for Earths. We should have been searching for oceans, not shallow seas under blue skies, but deep global oceans under heavy atmospheres. Places where chemistry is protected, where time stretches, where evolution can afford to take its time. K218b fits that picture almost too well. And now that we've seen one, we won't be able to unsee the pattern. Future telescopes will find more, some closer, some stranger, some with different gases, different temperatures, different chemistries, but many will share the same trait: stability. And when that happens, the question will no longer be whether life exists elsewhere. It will be why we ever thought it wouldn't. At that point, humanity will face a choice, not about exploration, but about interpretation. Do we see ourselves as exceptional because we are intelligent? Or do we see ourselves as young, noisy members of a much older, quieter family of living worlds? K218b doesn't answer that question directly, but it invites us to ask it honestly. And honesty, more than technology, may be what determines whether we last long enough to keep listening. As that thought lingers, another realization quietly takes shape, one that scientists don't usually say out loud because it doesn't fit neatly into charts or confidence intervals. If K218b truly hosts life, then whatever lives there did not just survive, it endured. And endurance in the universe is everything. Life on Earth has always lived on borrowed time. Asteroid impacts, ice ages, solar changes, mass extinctions. We are the product of interruption after interruption. Evolution here is fast because it has to be. Adapt or vanish, change or die. Our biology is shaped by panic written into geology. But on K218b, panic may never have existed. The steady glow of its red dwarf star removes urgency. There is no ticking clock of a star burning itself out. There is no sudden spike of radiation to reset the planet every few 100 million years. There is only continuity, a slow unfolding of chemistry that never had to hurry. And when life doesn't hurry, it changes differently. On Earth, intelligence may be a response to instability, a tool to predict, to escape, to control. But on a world where nothing needs escaping, intelligence might not look like us at all. It may not build tools. It may not invent fire. It may not need to conquer its environment because the environment never turned hostile. Life there could be vast, abundant, and profoundly non-competitive. That idea alone unsettles decades of assumptions. We tend to equate intelligence with progress, with technology, with visibility. But K218b reminds us that survival doesn't require dominance. It requires fit. And perfect fit produces silence. This is why the planet does not glow with artificial lights, why it does not broadcast radio waves, why it does not announce itself. It doesn't need to. Its atmosphere speaks for it. Every molecule Webb detects is a word in a language written by metabolism. Methane rising where it shouldn't. Carbon dioxide being recycled instead of accumulating. Water vapor remaining stable instead of collapsing into ice or steam. This is not chaos, it's regulation. And regulation implies feedback. Feedback implies processes that respond to change. Processes that respond to change are, by definition, alive. The more data accumulates, the harder it becomes to explain these signals without invoking biology. Exotic chemistry fails. Volcanism fails. Photochemical reactions fail. Every non-living explanation requires more assumptions than the living one. That's why the confidence number matters. 99.7% is not a headline gimmick. It's the point where doubt becomes unreasonable. And yet, the most profound consequence of this discovery has nothing to do with that planet at all. It has to do with distance. K218b is 120 light years away. That sounds impossibly far. Too far to matter, too far to reach, too far to touch. But in cosmic terms, it's next door. Our galaxy is more than 100,000 light years across. This world sits within a tiny fraction of that span, close enough that its light reaches us before a human lifetime passes. Close enough that its biology may have already outlived our entire species' history many times over, which raises a quiet, unsettling thought. If life exists there, it almost certainly exists elsewhere. Not as rare miracles, but as common outcomes. Not as exceptions, but as defaults. K218b may not be special. It may be typical. And if that's true, then the universe isn't just capable of producing life. It prefers to. The same laws of physics that shape stars and galaxies also shape cells and ecosystems. Gravity gathers matter. Chemistry organizes complexity. Time allows refinement. Life is not an accident layered on top of the universe. It is a natural expression of it. This perspective changes how we interpret silence in the cosmos. The famous question, where is everyone, assumes intelligence wants to announce itself, that it wants to expand, explore, and communicate. But K218b suggests another answer. Maybe most life never leaves home. Maybe it doesn't need to. A stable ocean world offers everything biology requires. Energy gradients, chemical diversity, protection from radiation, time beyond imagination. Why leave that? Space is harsh. Vacuum is lethal. Stars are dangerous. Planets like Earth are violent by comparison. Why would a mature biosphere abandon perfection? From that angle, silence is not eerie, it is sensible. And that brings us to the role of telescopes, like Webb. We are not overhearing conversations. We are eavesdropping on breathing. Webb is not detecting messages. It is detecting metabolism, the quiet background activity of a living planet doing what it has always done. And for the first time, we are sensitive enough to notice. That sensitivity will only increase. Upcoming observatories like the Vera-Rubin Observatory will map billions of stars and thousands of exoplanets. Future missions proposed by NASA's Jet Propulsion Laboratory and the European Space Agency aim to directly image Earth-sized worlds. The Harvard-Smithsonian Center for Astrophysics is already refining models to identify biosignatures in hydrogen-rich atmospheres, like K218b's. This discovery is not an endpoint. It is a calibration. Now that we know what to look for, the universe will start revealing it everywhere. And when that happens, humanity will face a shift as deep as the Copernican revolution. Earth will no longer be the reference point for life. It will be one example among many. Not the center, not the template, just one variation. That realization doesn't diminish us. It contextualizes us. It tells us we are part of something much larger, older, and more patient than we imagined. And patience, more than power, appears to be the universe's preferred strategy. The planet orbiting that quiet red star has likely been alive longer than mammals have existed on Earth, longer than trees, longer than oxygen in our atmosphere. Its story has unfolded without drama, without witnesses, without applause, until now. Now, a mirror made of gold and cooled to near absolute zero, floating 1,000,000 miles from Earth, has caught its breath in light. And once you recognize that breath, you can never look at the night sky the same way again. Because the darkness between the stars is no longer empty. It is waiting. And as that understanding sinks deeper, another question quietly rises, one that goes beyond science and slips into something more personal. What does it mean to grow up in a universe that is already alive? For generations, humanity carried a hidden assumption that life was fragile, that it needed perfect conditions, that it was rare, precious, almost miraculous. That assumption shaped our myths, our religions, even our science. Life was something to defend against a hostile universe. K218b flips that story. It suggests the universe is not hostile to life at all. It may be optimized for it. The chemistry that sustains that distant world is not exotic. Hydrogen, carbon, oxygen, sulfur. The same ingredients scattered everywhere. The same building blocks that formed our oceans, our cells, our bones. There is no special recipe, no rare element, no cosmic coincidence, just time, balance, and patience. That realization is quietly destabilizing. Because if life emerges wherever conditions remain stable long enough, then Earth is not a miracle. It is a phase, a step along a much larger continuum of living worlds. And that forces us to confront something uncomfortable, that we may not be early, we may be late. K218b star has likely been burning for billions of years before our sun even formed. Its planet may have hosted oceans while Earth was still molten rock. Life there could have risen, diversified, stabilized, and settled into equilibrium long before our planet cooled enough to form its first seas. If intelligence ever arose there, it would have had time beyond imagination to either transform or disappear, which raises a possibility scientists rarely voice, not because it lacks evidence, but because it lacks comfort. That intelligence may not be the final goal of evolution. It may be a temporary state. On Earth, intelligence brought control. Control brought speed. Speed brought instability. Every technological leap amplified our reach, but also our risk. The more we shaped our environment, the more fragile that environment became. On a world like K218b, evolution may have taken a different path, one where adaptation favored harmony over dominance, where systems learned to regulate rather than expand, where survival meant staying invisible rather than becoming loud. Such a biosphere would leave no ruins, no satellites, no radio noise, no megastructures, just chemistry doing what it has always done, perfectly tuned to its surroundings. From our perspective, that looks like silence. From nature's perspective, it looks like success. This reframes one of the most famous questions in science. Not where is everyone, but why would anyone announce themselves at all? Perhaps civilizations that shout don't last long enough to be heard. Perhaps the longest lived forms of life are the quiet ones. And that makes K218b even more unsettling, because its biosignatures are not dramatic. They are subtle, persistent, unchanging, the mark of something that has been stable for a very long time. In science, stability over time is the strongest evidence there is. That's why researchers at institutions like the Harvard-Smithsonian Center for Astrophysics are treating this discovery with such caution. Extraordinary claims require extraordinary evidence, and that evidence doesn't come from excitement. It comes from repetition. Each time Webb observes the planet, the same chemical patterns appear, the same ratios, the same absence of collapse, the same quiet imbalance that only life maintains. No drift, no decay, just continuity. And continuity is hard to fake. As more observation time is allocated, teams are beginning to model what kinds of ecosystems could maintain such an atmosphere. Not forests, not animals as we know them, but microbial oceans on a planetary scale. Trillions upon trillions of organisms cycling chemicals endlessly, invisible individually, unstoppable collectively. On Earth, microbes dominate life by mass and resilience. They survive deep underground, inside rocks, in boiling vents, frozen ice, radioactive waste. They are the foundation beneath everything larger. On K218b, microbes may not be the foundation. They may be the whole story. An ocean world ruled by chemistry, not competition. By cycles, not hierarchies. A planet where life never needed to become large, fast, or clever, because it never faced extinction-level threats. If that's true, then intelligence like ours may be the exception, not the rule. A product of unstable environments rather than optimal ones. That idea changes how we search. Instead of asking which planets could host beings like us, we begin asking which planets don't need beings like us at all. Because life doesn't aim for consciousness. It aims for persistence. And persistence is exactly what K218b appears to have mastered. This discovery also forces a quieter, more sobering reflection, that Earth's future may depend on whether we learn that lesson. We live on a planet that once had its own equilibrium, a balance maintained for millions of years. And in a few centuries, we disrupted it faster than any asteroid or ice age ever could. In contrast, the planet orbiting that red dwarf shows what happens when chemistry and climate remain aligned. It survives. It endures. It breathes. Perhaps the most powerful part of this discovery is not the confirmation of life elsewhere, but the reminder of what life requires everywhere. Not dominance, not speed, not noise, balance, and time. The universe, it seems, rewards those who learn to stay. And as we continue to study K218b, as Webb keeps listening to its quiet breath across the void, we may discover that the most advanced worlds are not the ones that reach for the stars. They are the ones that never need to. And once that idea settles, another layer unfolds. One that changes not just how we think about distant worlds, but how we think about time itself. Time on Earth is sharp. It is divided into days, years, generations. Civilizations rise and fall in what, cosmically speaking, is a blink. Our history feels long to us, but to the universe, it barely registers. K218b exists on a different clock. Around a red dwarf star, time stretches. Stellar evolution slows to a crawl. Geological cycles move with patience. Climate doesn't swing wildly. Oceans don't vanish and return. Everything that matters happens slowly enough for chemistry to keep up. That slowness is not a weakness, it's an advantage. On Earth, life had to race against catastrophe. On K218b, life may have had the luxury of refinement. Instead of surviving disaster after disaster, it could optimize. Instead of rebuilding after collapse, it could deepen. This introduces a concept scientists are only beginning to explore seriously. Not the emergence of life, but the maturity of life. Most discussions focus on how life begins, but K218b invites a different question. What does life look like after billions of uninterrupted years? On Earth, we have no example of that. Every complex ecosystem here has been reset again and again. Even our oldest life forms are shaped by extinction events. We are descendants of survivors, not continuations of stability. K218b may represent something we've never seen, a biosphere that never had to start over. If that's true, then its biology may be deeply alien, not because it's strange, but because it's complete, finished in a way we don't recognize. No rush toward complexity, no arms race, no explosion of forms, just efficiency layered on efficiency. In such a world, evolution would favor systems that last, not systems that grow fast. Metabolisms would be conservative. Energy use would be precise. Waste would be minimal. Every molecule recycled, reused, repurposed endlessly. That kind of life would be almost invisible from afar, which explains something important. We didn't find K218b by seeing something obvious. We didn't spot cities, lights, or structures. We found it by noticing imbalance so subtle it took the most sensitive telescope ever built to detect. Life there doesn't announce itself. It leaks. It seeps into the atmosphere, molecule by molecule, breath by breath, cycle by cycle. And that may be the most universal signature of life anywhere. Not construction, not communication, but chemical persistence. This idea is beginning to ripple through the scientific community. Researchers at NASA's Jet Propulsion Laboratory and the European Southern Observatory are quietly revising search models. Instead of focusing on oxygen alone, they're widening the net. Methane in combination with carbon dioxide. Sulfur compounds in unexpected ratios. Gases that shouldn't coexist unless something keeps pushing them out of balance. K218b is the proof of concept. It tells us that life doesn't have to resemble Earth to be undeniable. And that has a consequence we can't ignore. If life is common and intelligence is rare, then most living worlds will never notice us, and we will never notice them unless we look very carefully. That shifts the narrative away from contact and toward coexistence. A galaxy filled not with civilizations shouting across space, but with quiet oceans breathing under distant suns. We may be surrounded by life and completely alone at the same time. This paradox is uncomfortable, but it fits the data. The universe is not empty. It is just quiet. And that quiet isn't a failure of communication. It's a feature of longevity. As Webb continues to observe K218b, scientists are planning the next steps. Longer observation windows, higher signal-to-noise ratios, searching for seasonal changes, looking for shifts that could indicate cycles like blooms, die-offs, or migrations in the planet's oceans. If those variations appear, it would be the closest thing to watching life in action beyond Earth. Not through a microscope, but through light. And if those signals remain steady year after year, that too would be telling. It would mean the biosphere is not just alive, but settled. Stable life is the rarest kind. Because stability requires cooperation at every level, between molecules, between chemistry and climate, between energy input and energy output. On Earth, we've never achieved that balance permanently. Our planet oscillates between extremes. And now, with human activity, those oscillations are speeding up. K218b stands as a counterexample, a reminder that another path exists. One where life integrates with its environment so completely that the two become indistinguishable. When we finally accept that, the discovery stops being about aliens. It becomes about perspective. We are no longer asking whether life exists elsewhere. We are asking whether we understand what life is trying to become. And perhaps the universe has already shown us the answer, written quietly in the atmosphere of a warm ocean world, glowing faintly under the steady light of a star that refuses to hurry. The lesson may be simple and deeply challenging. Life lasts longest when it learns to stay in balance. And balance, once achieved, leaves very little trace until someone patient enough finally learns how to look. If we stay with that thought, another realization starts to form, one that doesn't come from speculation, but from comparison. When scientists line up K218b next to every other potentially habitable world we've found so far, something stands out immediately. This planet doesn't sit at the edge of survivability. It sits comfortably inside it. Most candidate worlds exist in narrow zones where one change in temperature or chemistry could sterilize everything. K218b is different. Its margin for error is enormous. That margin changes the rules. On Earth, life survives despite instability. On K218b, life could thrive because of stability. And that distinction matters more than we ever realized. A stable world doesn't just allow life to exist. It allows complexity to layer slowly, carefully, without being torn apart. Chemical networks can become dense. Feedback loops can grow sophisticated. Entire ecosystems can interlock without collapse. Over time, life stops reacting to its environment and begins shaping it gently, persistently. This is why the atmospheric signals Webb detected are so important. They don't spike, they don't crash, they hover, they fluctuate within tight bounds, as if regulated. On Earth, regulation comes from life. Forests control carbon. Oceans buffer temperature. Microbes manage nitrogen. Without biology, the system breaks. K218b's atmosphere behaves as if something is doing that work. And that leads to an uncomfortable but unavoidable idea. If this planet truly hosts life, then that life may be older than anything on Earth. Not just older than humans, older than multicellular organisms, older than complex nervous systems, possibly older than our planet itself. Red dwarf stars formed early in the galaxy's history. Some are billions of years older than the Sun. Their planets had a head start. While Earth was still cooling from impacts, worlds like K218b may already have had oceans settling into balance. That means life there didn't just begin early. It had time to experiment. If intelligence emerges from biology, given enough time and stability, then K218b raises a profound question. Not whether life exists there, but what stage it might be in. However, there's a crucial detail we must not ignore. James Webb did not detect technology. No artificial lights, no radio emissions, no atmospheric pollutants that scream industry, no sudden energy signatures that suggest machines, and that absence is just as important as what we did detect. It suggests that if life exists there, it may not follow our path. It may not build cities. It may not burn fuel. It may not communicate loudly. It may never invent technology at all. On Earth, intelligence and technology became linked because of scarcity and competition. We needed tools to survive changing climates, predators, and each other. But on a world where conditions remain stable for billions of years, those pressures may never arise. Why build machines if your environment already works? Why expand if nothing threatens you? Why transmit signals if there is no urgency? This is where K218b quietly reshapes the famous question, where is everyone? Maybe they're not hiding. Maybe they're simply not broadcasting. Life doesn't naturally evolve toward noise. Noise is a byproduct of struggle. Silence is what happens when struggle fades. And suddenly, the universe feels less empty and more reserved. The fact that we found this planet through chemistry rather than communication may be exactly how discovery was always meant to happen, not through messages sent on purpose, but through side effects of living. Breathing leaves traces. Metabolism leaves fingerprints. Existence leaves imbalance. And Webb was built to notice imbalance. As researchers at the Harvard-Smithsonian Center for Astrophysics have pointed out, the most reliable biosignatures are not dramatic signals, but boring ones. Gases that shouldn't coexist. Ratios that shouldn't hold. Patterns that refuse to settle into equilibrium. Life is stubborn that way. It never lets chemistry relax. What's striking is how gently K218b seems to resist equilibrium. There's no sign of runaway processes, no toxic accumulation, no collapse into a dead state. The planet looks like it has found a rhythm and kept it. That rhythm could have lasted hundreds of millions of years, or billions, which brings us to another sobering thought. If K218b hosts life, and that life is stable, then extinction may be rare there. Evolution would slow as systems approach efficiency. Change would happen, but subtly, gradually, almost imperceptibly. From our perspective, that might look like stagnation. From nature's perspective, it's perfection. And if intelligence arises in such an environment, it might look nothing like us. It might not prioritize curiosity. It might not explore. It might not leave its world. It could be deeply local, deeply rooted content, which means the universe could be full of life that never leaves home. Worlds that bloom, stabilize, and quietly endure under stars that outlive galaxies. That possibility forces us to confront something about ourselves. Our obsession with discovery, expansion, and contact may not be universal. It may be a symptom of instability, a response to living on a restless planet around a star with a deadline. K218b does not face that deadline. Its sun will burn long after the Milky Way reshapes itself. Its oceans may still be warm when our solar system is a cold memory drifting through interstellar space. We may be the brief ones, the exception, not the rule. And that flips the emotional weight of this discovery. Instead of asking whether life exists elsewhere, we are forced to ask whether our version of life is the strange one. Fast, loud, restless, short-lived. K218b suggests another mode of existence is possible, one built on patience rather than progress, balance rather than growth, continuity rather than expansion. James Webb did not just show us a living planet. It showed us a mirror that doesn't reflect our face. It reflects what we could have been under different stars, and perhaps what we might still become if we learn how to slow down enough to listen to the quiet signals life leaves behind. And then the weight of it finally lands. Not all at once, not like an explosion, more like a slow pressure building in the chest as the meaning becomes impossible to ignore. Because this is the moment the search changes forever. For the first time in human history, we are not arguing about probability or imagination. We are staring at a world where the math itself is pointing in one direction. A planet whose atmosphere refuses to settle into lifeless balance. A chemistry that keeps correcting itself. A system that behaves the way living systems behave, even when no one is watching. This is not a headline built on hope. It's built on light that traveled 120 years, passed through an alien sky, and arrived carrying evidence it could not fake. If that light is telling the truth, then life is not rare. It is not fragile. It is not something that sparks once and vanishes. It is something that emerges wherever conditions allow patience. And that realization is bigger than aliens. It means the universe does not struggle to make life. It defaults to it. The terrifying part is not that we found a living planet. The terrifying part is how quiet the universe stayed while doing it. No warnings, no announcements, no dramatic reveal. Just a steady glow from a red star and an atmosphere quietly breathing for billions of years. Life didn't wave, it waited. That changes how we see ourselves. We are no longer explorers shouting into a silent void. We are late listeners just learning how to hear whispers that have been there the entire time. K218b doesn't prove that intelligent civilizations are common. It proves something more unsettling. That life can thrive perfectly well without ever becoming loud, technological, or curious about the stars. It suggests that intelligence may not be the end goal of biology. Stability might be. And if that's true, then the universe may be full of worlds that are alive, aware in their own way, and utterly uninterested in us. Not hostile, not friendly, just complete. That idea humbles everything we thought mattered. It tells us that Earth is not the standard. We are one experiment among many. A fast-burning one, a noisy one, a fragile one. Somewhere in Leo, under a dim red sun that will outlive our galaxy, an ocean world may still be breathing calmly, long after our cities crumble and our signals fade into background noise. And that planet will never know we existed, or maybe it already does. Because the final truth is this: the moment we detected that atmosphere, the moment we read those molecules, the moment we assigned that 99.7% confidence, the universe crossed the line with us. We are no longer searching. We are confirming. And once confirmation exists, there is no going back to cosmic loneliness. No comfort in the idea that life is special because it is rare. Life is special because it endures. And now that we know that, the question is no longer whether we are alone. The question is whether we are ready to accept that the universe was alive long before we learned how to look. If you want to stay with this story as new data arrives and the next discoveries push this even further, subscribe and watch the next video on your screen, because this isn't the end of the search. It's the moment the universe finally answered.